So we have different sources of energy. So it may be either renewable type of energy sources or it may be non-renewable energy sources. So we'll see this renewable and non-renewable energy sources one by one. Now, what is meant by a renewable source of energy? A renewable energy, we can say various sources of energy that may be classified into mainly two types. One is renewable source of energy, and another one is the non-renewable source of energy. A renewable form of energy that can be regenerated, and the source of energy is infinite. So this is the renewable form of energy where the energy can be regenerated and the source of this energy it is infinite. And for example, what are the different forms of renewable energy sources? It may be solar energy, it may be wind energy, it may be tidal energy, it may be geothermal energy. So these are the different forms of energy. Like here is solar, geothermal, this is tidal, wind, and biomass. So these are the different forms of source of energy which are renewable source of energy. Now, in contrast to this renewable source of energy, we have non-renewable energy sources. So this non-renewable energy sources, it cannot be regenerated. We cannot regenerate these forms of energy, and its source is limited. It is not infinite. These are limited in the source, or we can say it is in the universe. So, for example, we have coal, petroleums, then we have fossil fuels, then nuclear. So these are the various examples of these non-renewable energy sources. So we have fossil fuels like oils, coals, nuclear energy, natural gases. So these are the some source of energy where these source are limited and we cannot regenerate this force. Okay, so this is are called as a renewable source of energy. Now we'll see. We can say a short information about this uh, either it may be a renewable source of energy or it may be a non renewable source of energy. So first we will see what is meant by renewable source of energy. So this renewable source comes from the sources that are theoretically we can renew as quickly as they we are consumed that. So if we used a sustainable rate, these sources will available for consumption of thousands of year or we can say longer. But unfortunately, some of potentially renewable energy sources such as biomass and geothermal are being depleted in some areas because of the usage rate exceeds over the renewal rate. But it can be regenerated. Now, first source of this renewable energy, it is the solar energy. So solar energy is the ultimate energy source, which is generally available in the earth through only a small fraction of solar energy that can be reached to the earth's surface and that sufficiently meet the world's energy requirement. And the process of converting this solar energy into either heat or either electricity is considered as a renewable energy source. So we convert this solar energy into either heat energy or into an electricity or electrical energy. So solar energy has been used to heat the homes, waters, and some modern technologies such as PV cells, that is photovoltaic cell, has provided a way to produce electricity from the sunlight. Now, if you see, there are two basic forms of this radiant solar energy. One is passive and another one is active. Now, what is meant by passive solar energy system? So passive solar energy systems are statics and do not require the input of energy in the form of moving parts or pumping fuels to utilize sun energy. Such as a building can be designed to capture and collect sun energy directly. Again, a sudden exposure to greenhouse with glass window and concrete floor is as another example of passive form of radiant solar energy. Now there are some active form of solar energy. Now, in case of active solar energy, we require input of some energy to drive the mechanical device, such as solar panel, which collects energy and pumps fluid used to store and distribute the energy. Another, solar panels are generally mounted on a south or west facing roof. A solar panel usually consists of glass faced and sealed insulated box with black matter interior finish. Inside there are coils full of heat collecting medium such as water. The sun heats the water in the coil, which is pumped through the coil and heat transfer tank containing water. The water in the tank heated and then either store or pumped through the building to heat or rooms. So it is one form of energy, that is solar energy. Another form of energy, it may be a photovoltaic cell. Okay, PV cell. So where direct solar energy gets converted into an electricity. Now we have another types of renewable energy sources. We can have a hydrogen energy also. So hydrogen or hydroelectric energy, it is hydroelectric power is generated by converting kinetic energy or pressure energy of water into a mechanical work. Like in case of hydropower energy, that is the tidal energy. So hydroelectric power is generated with the help of dam across the river. One in case of hydroelectric energy, and hydropower energy, it is the tidal energy. Another form of energy, it is the tidal energy. Next, we have wind energy. So in case of wind energy, wind is a result of the sun uneven heating. So because of sun uneven heating of the atmosphere, the wind is generated and the warm air expands and rise, and that cools the air, contracts and sinks. So this movement of air is called as a wind. So the wind has been used as energy sources for a long time. It has been used to pump the water, to power the sheep and some mill grains also. So areas with constant and strong winds can be used by wind turbines to generate electricity also. So the major drawback these wind power generators are they require lots of open lands and fairly constant wind supply. So windmills are also more noisy, and some people consider them one aesthetically unappealing and label them as visual pollutions. So this is a wind power. Now we have another type of renewable source of energy, that is biomass energy. So if you see biomass energy, it is the oldest source of energy source used by human beings. So it is an organic matter that composes with tissue of plants and animals. So it can be burnt for heating, cooking, and even for generating the electricity also. Now we have another source of energy, that is a geothermal form of energy. So geothermal energy also uses a heat from Earth's internal geological processes in order to produce the electricity. So one source of geothermal energy, it is the steam energy. So this is a renewable form of energy. Now we have different non-renewable forms of energy. Like we can say over 85% of energy used in the world is in the form of non-renewable source of energy. So about 85% of energy we used, it is a non-renewable source of energy. That is from oil, coal, nuclear, natural gas, all that. So most of the developed nations are dependent on these non-renewable energy sources such as fossil fuels. It may be coal, oil, and nuclear powers. So these sources are called as non-renewable because of they cannot be renewed or regenerated quickly enough to keep pace of their use. Now we will see this one by one, these sources. So first course is coal. First non-renewable energy source is coal. So coal is the most abundant fossil fuel in the world with an estimated reserve of almost 1 trillion metric ton. So coal has a 1 trillion metric ton reserve will be there in the world. So coal is formed slowly over millions of years from the buried remains of ancient swamp plants. During the formation of coal, the carbonous matter was first compressed into a spongy material called as peat, which is about 95% of water is there. That is called as a peat. As the peat become more deeply buried and the increased pressure and temperature turn into a coal part. So different types of coal resulted from different pressure and temperature that prevailed during formation. The softest coal, which having about 50% of carbon, so that is called as a softest coal, which is has also has low energy house. So it is called as lignite. So lignite has highest water content, that is about 50%, and relatively low amount of smoke causing sulfur. So with increasing temperature and pressure, lignite is transferred into a bituminous coal where there is 85% of carbon and 3% of water. Now we have another type, that is anthracite, which having almost 100% of carbon, is the hardest coal and also produced the greatest energy when we burn that. Now another form of non-renewable energy, it is oil. So crude oil, or we can say liquid petroleum, is a fossil fuel that is refined into many different energy products. For example, gasoline, then diesel fuel, jet fuel, heating oils. So these are the different forms of oils that can be used. Then we have natural gas, next form of non-renewable energy, that is the natural gas. So natural gas production is a byproduct of oil recovery process. So they are commonly shares underground reservoirs. Natural gas is mixture of gases, and the most common being a methane, CH4. So it is also contains ethane, propane, then butane. The natural gas is usually non-contaminated with sulfur, and it is the cleanest burning fossil fuels. So again, we have some LPGs, that is liquid petroleum gas. These are there, which is the natural gas, LPG. Then we have CNG, compressed natural gas. And the next last non-renewable energy source, that is the nuclear energy. So if you see this nuclear energy, it is the most electric power plant where water is heated and converted into steam, and then that drives the turbine and that produces the electricity. So in fossil fuel power plants, we produce heat by burning either oil or coal. But in case of nuclear power plant, we use the nuclear substances to heat this water, and we convert that water into a steam. So we have different forms of this nuclear power plant. It may be we have the several commercial reactors we required for that. Then we have uranium fuel is there, thorium fuel is there. So that is used in case of this nuclear power plant. So these are the different sources of energy that we have seen. It may be some of the sources, it may be renewable energy sources. Some of the well will be a non-renewable energy sources. Now we will see the first power plant that is known as we can say it is a power plant which is based on your mainly coal, that is called as thermal power plant, or it is also called as a steam power plant. Okay, so we'll start with this first power plant, that is thermal or steam power plant. So if you see a thermal power plant, it may be also called as a coal based power plant, or it is also called as gas based power plant. So thermal power plant has a different names. It may be a thermal power plant, it is also called as steam power plant, or it may be also called as coal based power plant, or it is also called as gas based power plant. So in coal based power plant, we use a burning fuel, that is a coal, and the heat energy after burning the heat energy get produced, and that heat energy is transferred to the water, and we convert water into a steam, and that steam is called as a superheated steam. Now what is mean by it is called as superheated? It is high pressure, high temperature steam. So superheated means we can have 100% dryness of the steam. So there is no moisture content, 0% of moisture is there. So that steam is called as a superheated steam. So again, the heat energy of that steam is get converted into a shaft power by using the expansion of steam into a steam turbine. So we convert heat energy into an mechanical energy or shaft power. Now this shaft of the steam turbine is coupled to the generator where we can produce the electricity. So if you see how the conversion of this energy takes place in steam power plant, starting from coal. So coal has chemical energy. So that chemical energy is then converted into, by burning of fuel, we converted into a heat energy. Then we convert, by using heat energy, we convert water into a steam. So that is known as thermal energy. And this thermal energy is impart on a steam turbine to convert it into mechanical energy. And the turbine is coupled to generator where we can convert mechanical energy into electrical energy. So in this way, we convert the chemical form of energy of coal into a electrical energy, that is electricity. Okay, so we cannot create, but we can convert one form of energy to another form, another to another form, so that we get the either work or we get either electricity. Now the exhaust steam from that steam turbine, it is again condensed by using condenser and cooling water. So condenser is just works like a heat exchanger where heat energy of steam is transferred into a cooling water, and steam is condensed in the form of again water. And this water is again pumped into the boiler. And the cooling water is recirculated through the cooling tower to release the heat. So if you see from this description, there are some parts of this thermal power plant. The first power part will be your boiler, where we can have the burning of fuel and conversion of that heat energy into steam energy. That is the first part. Next, we have a steam turbine where we convert that heat energy into thermal energy, and thermal energy get converted into mechanical energy by using this steam turbine. Again, part we have a generator where we convert the mechanical energy into electrical energy by means of generator. Now we have another part that is called as condenser, where we use the exhaust steam that converted into a water, and this water, it is again fed to the boiler by using the feed pump. So if you see, there are mainly four parts of this power plant. Another part is required, but mainly four parts. We have boiler, we have steam turbine, then we have generator, condenser, and feed pump. So these are the some parts. So we will see the block diagram of this thermal power plant. So if you see a block diagram of thermal power plant, there are different parts of this steam power plants. So first part, it is a boiler. So this is the boiler, it is your first part. Then steam turbine, it is your second part. Third part, it is the generator. Fourth part, it is condenser. Fifth part or component, it is pump, or it is also called as a feed water pump. Then another part is there that is called as a cooling tower. It is the sixth part. Now in boiler we have another two parts is there. So one part is superheater, which converts steam into superheated steam. That is superheater. Next part is economizer. This is another part that is called as economizer. And ninth part will be flue gases, that is one gases from this coal. It is passes through atmosphere by using a chimney part. So if you see, there are 9 part of this steam or thermal power plant. Mainly it is boiler, steam turbine, generator, condenser, then feed water pump or feed pump. Then we have cooling tower, then superheater, economizer, and chimney. Now, how working of this thermal power plant or steam power plant will be done, we will see. And then we will see the different parts of this thermal power plant, and we will see the function of each part. So if you see, in boiler, we have the pump input. It is low pressure, low temperature water. So we have low pressure, low temperature water. It is given to the pump. Now the pump is used to convert water, or we can say pressurize the water. So we convert this low pressure water into high pressure, low temperature water. High pressure, low temperature water. So input to the pump is low pressure, low temperature water, and output from pump is high pressure, low temperature water. Now this water is supplied to the boiler, where the heat energy is converted this water into a steam, and we convert that steam into a superheated steam. So we have converted high pressure, high temperature steam. So output of this boiler is high pressure, high temperature steam. Now this high pressure, high temperature steam, it is imparts to the steam turbine, and because of this high pressure, high temperature steam turbine gets rotated. That will produce the work, and the shaft of this steam turbine, it gets rotating. Now this high pressure, high temperature steam, when imparts from this steam turbine, it converts into again low pressure, low temperature steam. Now here it is again a steam, low pressure, low temperature. This is the steam part. And the steam turbine rotate. Now steam turbine is connected to generator, so it will rotate the generator, and we get produce the electricity or electrical energy. Now this low pressure, low temperature steam, or we can say it is the exhaust steam, it is passes through the condenser part, where we can convert this low pressure, low temperature steam into condensate water, or we can say a water. So again we get this low pressure, low temperature water. So we can recirculate this water through this cycle. So we have this cycle completed. So starting from this low pressure, low temperature water, it gets supplied to the boiler. We get high pressure, high temperature steam. Then we supply to the turbine. We get work, and that high pressure, high temperature steam, it get converted into low pressure, low temperature steam. And this low pressure, low temperature steam, it again converted into a low pressure, low temperature water by means of condenser. So this is the working of a block diagram, and some working of this thermal power plant, how energy is transferred from coal to the electrical energy. So this is the block diagram of this thermal power plant or steam power plant. Now we will see the different components of this power plant. So the first component is boiler. So a coal, it is fed to the boiler with preheated air, and the boiler is used to produce high pressure steam. The main function of boiler is to produce high pressure steam. So the boiler in thermal power plant, it is used to convert chemical energy of coal into a thermal energy or heat energy. So we convert chemical energy into thermal energy or heat energy. So that is high pressure steam. So during the combustion of coal, the high temperature is produced inside the boiler, and this temperature is high enough to convert water into a steam. So the size of boiler, it maybe depends upon the heat required for this thermal power plant. And we can have, there are several types of boilers that is used in thermal power plant. It may be uh, Babcock-Wilcox type of boiler, or it may be a fire tube boiler, or it may be water tube boiler that is mainly used in this thermal power plant. So this is the first part. It is called as boiler. Now second part, it is the turbine. So turbine, where the high pressure, high temperature steam is fed from boiler, it is passes to the, or it is superheated steam, it is strike on turbine blade, and turbine starts rotating. So the turbine, it is a mechanical device which converts heat energy of steam into a rotational energy or kinetic energy. So rotational energy of a shaft or kinetic energy of a shaft. So this is the function of turbine, which converts a turbine. It is a mechanical device which converts heat energy of steam into a rotational energy or kinetic energy. So the turbine is mechanically coupled with alternator or generator via shaft. When steam released from turbine, the temperature as well as the pressure of steam, it is decreasing. And this low pressure, low temperature steam, it is then passes through the condenser. So this is the function of turbine. Now we have another part that is called as a condenser. So when steam released from turbine, the temperature and pressure gets decreased. And this exhaust steam of turbine, we can use this exhaust steam of turbine in the cycle. Now, why to use this exhaust steam? To increase the turbine efficiency. Now, to use this steam, we have to convert steam into water. And for that, we require a part that is known as condenser. So we need to condense this steam to maintain a proper vacuum, and the condensation decreases the operating pressure. So vacuum is increased, and it will increase the volume of steam, and that results the more amount of work from the turbine. So and due to this, the plant efficiency again increases by using this condenser. So we increases turbine output, and from the turbine output, we can increase again the efficiency of steam power. So these are the functions of components of steam power plant: boiler, turbine, and condenser. And we have seen these functions of each parts. Now we have next part. It is a feed water pump. So that is mainly used in a steam power plant to feed the water into high pressure, or we can say a feed water pump is used to supply water into the boiler. So high pressure water, it can be supplied to the boiler. So a feed water pump is used to supply water into the boiler, and the water may be from condenser, or either we can use a fresh water. So this pump, it can be used the water from condenser, that is reuse of a steam, or we can have a fresh water also. So this pump is used to pressurize the water. Okay, so we can increase the pressure of water. So generally, the feed water pump, it is either a centrifugal type or positive displacement type of pump will be. So this is the fourth part. Now we have fifth part, which is alternator, or it is also called as a generator. So the alternator and turbine, they are connected on same shaft. When turbine rotates with the flow of steam, the alternator get also rotates, and the rotor of alternator rotates, which generates the electricity or electrical energy. Therefore, alternator, it is a device which is used to convert kinetic energy or rotational energy into an electrical energy. So this is the function of the alternator or generator. Now, these are the main parts, but other parts of this steam power plant is very much essential. Okay, so first part in that it is the chimney. Now, in most of thermal power plant, which are having a coal which is used as a fuel, during combustion of coal, the flue gases are generated by inside the boiler, so or we can say inside the furnace, and the chimney provides a path to flow of these flue gases and exhaust these flue gases into an atmosphere. So this is the function of chimney. Another part, it is the cooling tower or component of steam power plant or thermal power plant. It is the cooling tower. So as name suggests, the cooling tower is used to reject waste heat into atmosphere. So there are different methods of heat transfer are used to cooling tower. The heat of water evaporates into atmosphere and remains cool water that further used in cycle. The condenser converted steam into water, and the water that comes from condenser is supplied to the cooling tower, and that further uses this water into a cycle. So generally, forced cooling towers are used in case of thermal power plant, and the air is circulated from the bottom to the top of the tower. So these are the functions of this feed water pump, alternator, generator, and cooling tower. Now we have remaining next two parts will be the superheater and economizer. So if you see these two parts, superheater and economizer. So what is meant by superheater? In steam turbine, the superheated steam, I have already told the meaning of superheated steam. It is dry steam, means there is no water moisture in the steam. That is called as a dry steam, or it is also called as a superheated steam. So in steam turbine, this superheated steam is used to rotate the turbine. The wet or saturated steam, it is supplied to the superheater. So what is the input for superheater? It is wet or saturated. Now what is meant by wet or saturated? We have moisture content in the steam. Okay, so that steam is called as wet steam or saturated steam. And superheated, it is a device which converts that wet and saturated steam into a dry and superheated steam. So that is the main function of superheater. The superheater's temperature is the highest among all other components of the thermal power. So highest temperature of all these components in the thermal power plant is at superheater. So in thermal power plant, there are three types of superheaters used. It may be convection, radiant type, convection type, and separately fired superheater. So the superheater is used to increase the temperature of steam generated from boiler, and this will increase the thermal energy of steam. So this is the function of superheater. Now we have another part, that is economizer. Now this superheater, it is used to increase again efficiency of thermal power plant. Now another part, we have economizer. So economizer, it is a one type of heat exchanger device that is used to reduce the energy consumption. How we reduce this energy consumption in boiler? So in boiler, we use this economizer part. So in the boiler, the flue gases which are exhausted to atmosphere. Now we use these gases, and these gases have high temperature. So economizer uses this heat of flue gases to heat the water. And the water released from condenser is again used to the cycle with the help of feed pump. So this water is transferred to the economizer, and economizer uses the heat of flue gases to increase the temperature of water. So if you see, we have increased the temperature of water, and economizer uses this waste heat of flue gases to increase the temperature, and hence we increase the efficiency of entire thermal cycle or cycle. So this is the different, we can say, parts or components of thermal or we can say steam power plant. Now we'll see the next part of this thermal or steam power plant, that is advantages of steam power plant. Now if you see, there are different advantages of this steam power plant. So first advantages is we use a fuel, that is coal, which is the cheaper fuel. So coal is cheaper fuel. Then this steam power plant, they respond quickly with changes in the load of the plant. Now we have again electricity which is not constant used by a customer, or we can say, so there is supply and demand that can be different for different conditions. So if you see, in daytime the supply is less, in morning 6 to 8, or in evening we have more requirement of energy. So this power plant, it is responds quickly to change in the load. Next, space requirement is less as compared to hydroelectric power plant for this steam power plant. Another is the portion of steam which is released from steam turbine that can be used as process the steam for various process industries. So portion of steam can be used as a process steam for various process industries. Now they can be overloaded up to 20% without any difficulties. So we can increase the overload on this thermal power plant. Then cost of electric generation and its initial cost is less as compared to a diesel power plant, or we can say other gas power plants. Then this steam power plant, it can be located near to the load centers, or you can say near to the distribution centers of electricity. Thus we can reduces the transmission loss, again loss of energy in transmission line, and also cost of transmission lines. So these are the different advantages of this steam or thermal power plant. And the last part of this thermal or steam power plant, it is disadvantages. So first is the operation and maintenance cost is high of this thermal power plant, because we have a number of parts and all these parts are mechanical parts. So operation as well as maintenance cost will be high. Second, the time needed for erection of plant is high before it put it into operations. Next one is large quantity of water is required, because we convert water into steam. So we require large quantity of water. Next one is the main problem in case of this steam power plant. It is the coal handling and the byproduct of this coal, burning of the coal, it is ash handling. These are the serious problems in case of steam power plant. So how we can handle the coal and how we can handle this ash, that is the byproduct after burning the coal. So this is the serious problem. Again, the part load efficiency is low. The pollution, because of this thermal power plant, flue gases we are use, but we can reuse that flue gases, but some of the pollution will be there, and that pollution causes the health problem to the workers or habitants which are near to this power plants. So in this lecture, we have seen what are the different sources of energy, what is energy, work, different types of energy sources. It may be renewable energy sources, it may be non-renewable energy sources. And we have uh, completed our first power plant, that is called as thermal power plant. That is mainly a coal-based power plant. So thank you for listening this. So thank you very much.